In this special edition of Drive, we'll take an in-depth look at the innermost workings of a Formula One team, a rare treat in the usually top-secret world of top-draw racing. Toyota Motorsport has been in Cologne in Germany since 1979. Over 600 employees from 32 different nations create the Toyota Formula One car under one roof.
Yeah, it's challenging, but I think that's the same in any modern business with a lot of people. And one thing is to share a common vision, and in Formula One people want to win. And probably it's easier than some other businesses if you can share that common vision, and people are very easy to motivate and follow that direction.
In order to win at the war, we think we need three things. One is the car itself and its background, which is just TMG. The second is the race team itself. And the third thing is the lineup of drivers.
Gustav Brunner and a team of chassis designers create the shape of the central F1 monocoque, gearbox, suspension, brakes and steering. Working closely with the aerodynamic designers taking test data from the in-house wind tunnel and the test and race teams collecting telemetry data, their job is one of constant evolution. Chassis designers, like the engine designers, use the most up-to-date computer-aided design technology in their daily work. But before chassis design gets to specific details, meetings between the chassis and engine departments take place to avoid possible conflicting requirements of the engine and gearbox, suspension and packaging of the thousands of parts. Half-scale models are created in the model shop and used for aerodynamic wind tunnel testing, built by a team of experienced model makers. The models are made of similar materials to the real cars, carbon fibre and aluminium. A typical model will take 4 to 6 weeks to build, although in reality most of the work is modification to existing models to add new ideas and designs. These rebuilds generally take around 10 days to complete. The team uses wind tunnel models in various configurations during the aerodynamic development program. The models are all half full size, referred to as 50% scale, and various parts can be quickly changed to experiment with different aerodynamic effects in the wind tunnel. The team makes many different front and rear wings, side pods and engine covers for this purpose. Each model is packed with sensitive measuring equipment and sensors to record exactly what's happening in the wind tunnel. Lessons learned in the wind tunnel are fed through to the design engineers, who analyse how best to put these improvements into the racing cars. The Toyota factory has its own wind tunnel for aerodynamic testing of the half-scale models. Few would disagree that the biggest gains in Formula One nowadays are made through aerodynamics, and the wind tunnel's role is to help the team find more downforce and reduce drag, therefore achieving a good balance between corner speed and straight-line speed. Consisting of a steel belt rolling road from the USA and a huge Canadian-made fan, the wind tunnel was designed as a partnership between Toyota Motorsport and a German engineering company in 1999. The tunnel has been fully operational since July 2002 and currently runs 7 days a week as the team employs in-house aero experts to find gains that will lift it up the grid. Since minute changes can affect the flow of air all over the car, aerodynamicists must prioritise their ideas. Often they will use computational flow dynamics computer software to test the worth of potential improvements before actually designing and making the part. This not only saves valuable time, but also minimises the risk of spending time and money researching changes that may not work. Some aspects of the car are difficult to predict, for example, pitch sensitivity, where the aerodynamics are affected by the pitching of a car under braking and acceleration, so the wind tunnel ultimately remains the best tool to simulate track conditions and to develop the car aerodynamically. As soon as an improvement is established by Toyota's aero department, new components can be manufactured and added to the wind tunnel models to test their theories. The rolling road accurately simulates the movement of the track beneath the car, even though the car in the tunnel is fixed and not actually moving. This is important as airflow around the bulky moving tyres also has an effect on the overall aero package. A staff of engineers maintains and operates the wind tunnel, which is capable of running at speeds in excess of 200 kilometres an hour, 24 hours a day. Managed by Luca Marmorini, the engine department is divided into 3 subsections: technical offices, workshop and test bench. The design team has been in place since 2001 with a good mix of young engineers new to Formula One and engineers with Formula One experience who have matured as a group. These designers work together in one office to create the 10-cylinder 3-litre engine from scratch. The design work is done using state-of-the-art CAD software. Engineers are able to produce individual drawings which together form the final product. To attain a balance of performance, reliability and lightweight in the engine, it takes in the region of 1,500 detailed CAD drawings to reach the final result.
When we design a new engine, the first meeting we have with chassis people to see what they're expecting from us to supply. So sometimes it may happen that from making the car quicker, we may design completely the engine just for fulfilling a chassis expectation, but this is part of our job, and Toyota can do this very well because we have all the team under the same roof.
The V10 engines are all hand-built by a dedicated group of skilled mechanics, half of whom have worked at Toyota Motorsport in Cologne for over 10 years. The engine workshop builds and rebuilds over 300 engines per year. It takes 2 men 4 to 5 days to assemble a single V10 engine, a 200-hour job.
The rules are very strict, so we have not possibility to do strange things. The number of cylinders are coming from the regulation, the displacement is coming from the regulation as well. But we are very proud of our way of working. I think each part going in the engine has a reason to be developed. This means it can be an improvement on the material, on the design. We have internal tooling and people able to calculate in a very state-of-art way any part. We can develop, we have a facility here to develop in a very sophisticated way any component. So normally when we are designing or producing a new part, this is because this represents an evolution.
Before being fitted into the car, every engine will be run on one of the team's 7 dynamometers to try and eliminate potential problems before getting to the racetrack. One of these dynos has been in use since Toyota's Rally and Le Mans days, but as the F1 program got underway, additional dynos were added to cope with the more powerful engines. In total, Toyota Motorsport has 2 single-cylinder, 2 transient and 3 static test benches. Highly qualified engineers use computers to monitor the engine's every beat from isolated control rooms. Development of each engine begins on a single-cylinder test bench, which gives highly accurate results and allows the engine department to be fully satisfied with the performance of one cylinder before producing a full 10-cylinder engine. Engineers are able to simulate the rigours of a race without the engines ever leaving the factory. By using data recorded at races, the engineers can subject it to the same cycles of acceleration and deceleration that it would experience at the track. The ultimate test of any Formula One engine is still the old Hockenheim ring, where engines would be at full revs for 17 seconds twice in a single lap. Improvements in engine performance during the season are not made at the expense of reliability. In its 2 years of Formula One competition to date, Toyota has only experienced engine failure in 2 races, underlining the team's meticulous engine manufacturing and testing processes. Even in today's high-tech world, hand skills such as bending and welding often take precedence over the technology. In the fabrication shop, a team of craftsmen from the motorsport, aviation and industrial worlds use traditional techniques and modern machinery to produce components which are sometimes more a work of art than a work of engineering. During the bending process of the exhaust system, the outside of the pipe is stretched and the inside of the pipe is compressed. All the pipes have the same length but are bent differently for efficiency and because of the limited space available. All developments of new exhaust systems are made in-house as the space in the car changes during the season, so being quick and flexible with changes is very important. Various non-destructive testing techniques, such as magnaflux and radiography, are used to check for defects. A typical exhaust system will take one man about 50 hours to produce. This department builds about 150 exhaust systems each year, including the ones used on the test benches for development as well as for racing and testing. A new exhaust system will be used for each race, which, after quality control, can be reused on the test bench or for testing. As well as the intricate exhaust systems made here, many other fabricated components are produced in-house, including wishbones, pipework, oil tanks and other parts impossible to be made by machines. The finished articles look like sinuous, gleaming art forms, almost too good to hide away under sleek carbon fibre bodywork, but that's where they're going. The Computer Numeric Control, or CNC, fabrication department produces many chassis and engine parts, as well as composite forms and moulds for carbon fibre manufacture. The CNC department is equipped with fast and powerful milling, grinding and drilling machines, many of which can handle up to 6 identical components in one machining cycle. As well as multitask capacity, all of the machines have extensive tool stations and can select between 30 and 120 different tools, depending on the task in hand. 5-axis milling machines are used to enable a degree of flexibility and accuracy in manufacturing, which is paramount in modern Formula One. These machines are capable of machining components over an area of 1 metre to an accuracy of 4 microns. That's about 25 times smaller than the thickness of a human hair. A range of materials are machined here, including aluminium and magnesium castings for engine blocks, cylinder heads, throttle valves and gearboxes, as well as synthetic materials used for the production of patterns. The design data that is processed by the CNC shop in a year is expected to be in the region of 2,000 plus megabytes, in addition to the 10,000 operator-loaded programs. The production of a cylinder head, for example, from the drawings to the finished product, takes 14 days and uses 320 different tools. Between 450 and 500 cylinder heads and around 150 crankcases are produced per year. The composites department is where all of the laminated components used in the construction of the chassis are produced. For this purpose, materials such as carbon and Kevlar fibre are used extensively. When a new car is developed, about 25 to 30 parts will be produced per day. The final monocoque is made out of 17 different moulds and takes 4 people 16 days to put together. All the carbon layers are cut from a roll of material using an accurate ultrasonic computer-controlled cutting machine. The various stages of composites manufacture start with the production of patterns. These are transferred to the composites area where moulds are made in carbon fibre. The moulds are prepared to a very high quality finish and are then thoroughly checked because the quality of the final components depends on the accuracy of the original moulds. The actual race car composite components are then taken from these moulds. The basic structure of a typical composite component is an aluminium honeycomb core onto which is laid interwoven carbon fibre cloth which has been infused with a resin that hardens with heat. This process, known as the layup stage, takes place in climate-controlled rooms, providing a dust-free air-conditioned environment. Once this layup process is complete, the mould and the laminates are packed together into a sealed vacuum bag ready for curing or baking. The curing takes place in one of the 3 autoclaves, a vessel that puts the components under pressure and temperature under controlled conditions, pushing the carbon layers together and then heating them to speed up and improve the hardening process of the resin. The curing process can be several hours long with temperatures around 200 degrees C. After the curing process, the strength of the carbon is greater than that of steel, but much lighter. After some trimming and final quality control, parts will be delivered to the F1 workshop, or if required, painted in-house before being added to the stores. To enable the engineers to create new parts very quickly and establish new installation concepts, state-of-the-art laser machines are used to produce high-accuracy, rapid prototypes of car components for either wind tunnel models or installation on actual cars. In the workshop, there are 5 working bays, 3 for the race cars and 2 for the test cars. 3 mechanics work in each bay, joined by 1 each for the gearbox, the hydraulics, the electrics and the engine. It is here that all the components come together.
Well, there's no great secrets in Formula One. The areas that give you most performance in terms of aerodynamics and everything everyone knows about, and I just prioritise them, apply the methodology that I've found to work, and I'm very, very confident here that that methodology is going to work, and hopefully in a shorter space of time because of the resources and the motivation that exists at Toyota.
The engine assembly, the electrics and the hydraulic assemblies for the engine and the chassis are delivered as a finished package from the respective departments. The gearbox will be completed in the suspension assembly and then delivered as a complete rear-end assembly, including suspension parts and brakes. The cars are built and then completely stripped and carefully reassembled between every race and test. This requires a team of technicians to check the 4,500 components on every car, and the engine is regarded as just one of those components. It's only through meticulous attention to detail that speed and reliability can be ensured when the cars are on the track. To set up a brand new car from scratch takes about 2 weeks. The rebuild after each race or test only 3 or 4 days. All assemblies are dismantled and returned to the respective departments for revision or recycling. At the same time, a new unit has been prepared and can be put in immediately.
If you look at Formula One, the same teams have won. The top 4 have been the top 4 for the last 15 years. For me, the challenge is to take someone from outside that, a new team, a great name in motorsport, and to win with them. And I think that would be a great personal challenge.
In the high-speed world of Formula One, with speeds of over 300 kilometers an hour and times measured in thousandths of a second, accuracy and safety depend on effective quality control. The Quality Control Department measures the accuracy of each component used in the car. As we've seen, each component is produced within very tight manufacturing tolerances, often of just a few microns. The Quality Control Department is involved in the process of manufacture, making sure that any concerns are pinpointed early on. QC is equipped with a range of state-of-the-art measurement equipment capable of measuring tolerances as small as 1 micron. Critical components are all tracked using a system of unique identification codes to ensure that they do not exceed their service life. This prevents component failure due to fatigue.
I mean, we're the only team really starting from zero, engine, chassis and team. And I think we want to get a better understanding of what Toyota represents as a company to the European consumer. And I think that benefit is coming through. I think the technology also of Toyota is becoming better understood. And on a global basis, I mean, Formula One is now reaching new markets. China, we are Turkey, India will probably be on the calendar soon. So it's actually approaching those new emerging markets where car development is really important. So I think I can say strategically, Formula One is very important to Toyota as a corporation.
Toyota's move into Formula One was a brave one, becoming only the 2nd manufacturer, after Ferrari, to build both their own chassis and drivetrain. Every other team, including the mighty Williams and McLaren, design and build their own cars but have outside engine suppliers. Since Toyota's arrival in Formula One, Renault bought the Benetton team, which was using Renault engines anyway. Illustrating how tough it is to succeed in Formula One, Toyota have had the services of various top-flight drivers, including Scotsman Alan McNish, Olivier Panis of France, and Brazilian champ car driver Cristiano da Mata. For 2005, German Ralf Schumacher, younger brother of 7-time world champion Michael, joins the team from Williams, and Italian Jarno Trulli comes to the team from Renault. For the team to function at all, tons of equipment needs to be transported to the track. 3 racing cars, spare engines, tyres, electronic equipment, countless parts, tools and the pit equipment itself. Virtually all of it is packed into sleek team transporters at the factory. Everything has a place and a specific order to be loaded and unloaded. The layout of the pit garage is always exactly the same, so that everyone will know precisely where everything is, whether they're testing at Paul Ricard, practicing at Sepang or racing in Dubai. Time spent trying to find a vital part or tool wastes valuable seconds. Besides the cars, there's the infrastructure needed to get them to and from the tracks, and how the equipment, parts and their transporters are looked after. Torsten Moos is one of many outside experts who work with members of the logistics crew. He's an expert on cleaning, particularly of vehicles and equipment.
Cleaning used to be done conventionally, that is, with scrubbers, with buckets, with brushes, all by hand. Today we have machines for all of that, which makes it a lot faster. And where else does time matter, as much as in Formula One?
Because of the short intervals between some of the races, pressure to reach the destination can be enormous, with little time to wash down the trucks. But keeping up appearances for the team's multi-million-dollar sponsors is vital. Just as racing cars now have technology to match anything in the aerospace or defence industries, the image of oil-stained drivers and mechanics with greasy hands has been replaced with immaculately presented professional technicians.
What we're doing now is only a crude pre-cleaning of the trucks. That means we're not doing a wheel cleaning or an insect cleaning. That's done later.
The truck wash. It's like a regular car wash, just twice the size, and tackles the dirt at a bracing 80 bar pressure. The first thing is to fit in perfectly, a millimetre-perfect job that gets easier with practice. At the track, the trucks have to fit into their allocated spaces, and the truckies take great pride in having the best-looking rig in the paddock. To do so means getting rid of dirt and brake dust from the wheels and splattered bugs on the front of the trucks.
We spray this wheel cleaner on and let it soak for about 2 minutes. After that, we rinse them down with cold water, and that should be it. This is another cleaning product. The entire front is sprayed with insect remover. This makes it easier to peel off the dead bugs which are stuck there. After that, just rinse with clean water using a hot water pressure cleaner.
The truck is required to be clean outside and inside too, and a range of professional tools help to do the job. Just having the equipment isn't everything. You still need to get down and scrub occasionally, and sometimes a hand wash is still the best. Once the trucks reach their destination, the crews will have other tasks, so they usually get the big rigs cleaned up first. The allocated pit area is cleaned too before anything is unloaded. Fitting out the pit with the team's furniture, tools, equipment and parts goes surprisingly quickly. After all, everyone's done it many times before, and packing up again afterwards goes equally fast. Having served an apprenticeship in Formula One, Toyota is now expected to start delivering some front-row results. They've certainly done their homework. So whether you're testing a new engine, building a new car, or putting it all to the test, so you stay on track and up to speed, make sure you catch next week's Drive.